Hi my friend, how are you? I am Joey. Welcome to Joey's Tech. In this video of Joey's Tech, we are going to solve palindromic partitioning problem using dynamic programming. Let's move to the problem statement right away. So you have a string, you got a string, and in this video we'll be using the string CBADA. So CBADA is the string upon which we are going to create our palindromic partitioning dynamic programming solution. Now the problem statement is that we have to find the minimum number of splits or cuts which when applied to this string CBADA it produces only palindromes as substrings. So the minimum number of splits which we are going to apply to this particular string, it is going to produce substrings which will be palindromes in themselves. All right. By the way, if you don't know what a palindrome is, or if you know already, then let me help you revise it. The palindrome is the string which is the same when read from right as well as from the left. All right. Examples include radar, level, rotor, etc. Now, if the problem statement is not clear to you up till now, then let me help you clear it up. So here is our string CBADA. All right. Now I was talking about splits and the minimum number of splits. So here are two splits which I am applying to this particular string. So I'm putting a split after C before B and another split after B before A. So as you can see, we are getting three palindromes here after two splits or two cuts. So the first palindrome is C because it's an individual letter, so it is a palindrome in itself. We cannot deny that. B is also an individual letter which is a palindrome in itself, and ADA is a genuine palindrome. Okay, it's a palindrome with more than one letter. All right, so minimum number of splits okay, that is required to produce palindromes, only palindromes as substrings is 2, and that is our solution. So let's jump to our framework where we are going to create a computing solution to reach to this number 2 on this string CBATA. Before we move to our framework, there is a humble request. If you are new to my channel, then do subscribe, okay, and do hit the bell icon because that way you get notified whenever I release new videos like this in future. So here we are at our framework. Now before I start filling this matrix which is over here, let me recommend you to watch one of my videos which I created on developing the intuition to solve the longest palindromic subsequence using dynamic programming. Now watching that video is really going to help you a lot. It is really going to help you develop the intuition to solve 6 to 7 dynamic programming problems like these, and it will help you build the base to solve such kind of problems. And palindrome partitioning is one of them. All right, so I highly recommend you to watch this video before proceeding ahead from here. All right, so like we are going to start from the lowest subproblem. All right, since this is a dynamic programming problem, so I will be starting from length equals to 1. Length equals to 1, that means all the individual letters are my subproblems. Okay, so I am going to take on the individual letters one by one. So I will be starting from this one over here, which is C. So how many splits are required to make C a palindrome? Now the answer is quite obvious that I require no splits because C is automatically a palindrome. All right, so I'm going to put 0 over here. Okay, so moving to B, how many splits are required to make B a palindrome? The answer is again going to be 0, and same it is going to be 0 for A, 0 for D, and 0 for A. So for individual letters It is common sense that we do not require any number of splits. All right. Now the length increases to 2. Okay. And the subproblem becomes CB. Okay. The first subproblem. So it will be represented by this cell, as you can see, C and B. Okay. Now the string which is under consideration is CB, and let's see how many splits can we put on this CB. So if we require no splits, then CB has to be a palindrome. Okay, so is it a palindrome? So is it a palindrome? I don't think it is a palindrome. So I'm going to mark it as red. So I can put only one split over here between C and B. Okay, one split. All right. So one split, that means the minimum which is going to come here, the minimum value which is going to be put in this cell is going to be 1 plus the splits from here. So what is the value over here? It is 0, and B is also 0. All right. So minimum split is going to be 1 because I'm putting one split over here. All right. And how many splits are required to make C a palindrome? It is 0 because I'm getting it from this cell C and C. So I am going to put 0 over here. All right. And minimum number of splits from B, which is 0 again. So I will add 0 to it. Okay. So it is going to give me 1, and 1 is my answer which I have put over here. Let's move to the second subproblem, which is going to be BA. All right. Is it a palindrome? No, it is not a palindrome. So I'm going to put it as red. All right. Now I am going to put a split between B and A. That is where we can put the split. And if you see, then 1 is the number of split which I am putting. So for B, I am getting the minimum number of splits again as 0. And for A, I am getting the minimum number of splits again as 0. So 1 plus 0 is going to be 1, and I am going to put 1 over here because this cell represents the value of BA. All right, BA. This is the way when you are solving it on your own, you have to proceed. Okay, just keep this in mind. Similarly, let's do it for AD. So AD is also not a palindrome. I am going to put A over here and D over here, and the answer is going to be the same. One split is required because I'm putting a split there, and then I'm getting the value of AA as 0. That means the minimum number of splits, and for D also 0. So I'm going to get 1 over here. For DA, which is going to be our last subproblem of length 1, we will get the same answer. Okay, so I will put 1 over here. Now the length of the subproblem increases to 3. So the first subproblem which comes under scanner is CBA. Is CBA a palindrome? No, it is not. So let's split it up. So I can split it this way, C and then BA. All right, let me eliminate all these to avoid confusion. Then C, B and A. All right, so I can put 2 splits over here. So let's examine this split first. So I will be getting 1 as the number of split. Then for C, what is the value I'm going to get? For C, I am going to get 0. All right. For BA, what is the minimum number of splits I'm going to get? So this is BA, as you can see, B and A. So I'm getting 1. Okay, 1. So I get 2 as the answer, which I am going to put over here. All right. Now for CB, now this is the second case which we are going to examine. So CB, the minimum number of splits is 1. All right, so it is going to be 1 plus 1 plus, for A, I am going to get the minimum number of splits as 0. So it is going to become 2 again. Now since 2 and 2 are equal, so 2 stays here in this value, in this cell. All right. Now the next string which comes under our scanner is going to be PAT, and these are the cases which are going to form when we are going to perform 2 splits on this particular string. All right, so it is going to be 1 already, plus what is the value of P I am getting? I am getting 0 from here, so it is going to be 0 plus AT. So AT is, as you can see, AT is 1. All right, AT. So AT is 1, so it makes it 2. Here, let's examine. So BA is 1. So 1 plus 1, and what is D? D is 0. All right, so this stays like this. I again get 2 over here. All right. This also means that whenever we have a string as PAD, then 2 splits are required. 2 is the minimum number of splits, okay, which is required. All right, now our string changes to ADA. Now, as you can see that ADA is a palindrome. So we don't have to put any kind of splits there because it is a string as well as a substring, which is a palindrome. Okay, we don't need to do anything here. We don't need to cut it so that we get palindrome, so that we get different palindromes, because this is already a palindrome. So what I'm going to put in ADA, since we do not require any splits, so I'm going to put 0 over here. As you can see, this cell represents ADA from A to A. All right. Okay, now the length of the subproblems increases to 4. So the first problem which comes under scanner is CBAT. Okay, let's put all the different cases here. So first is going to be CBAD, then CBAD. Okay, if you notice, I'm writing some of the subproblems which I have solved earlier, and that is the beauty of dynamic programming. So CBAD. Okay, so we can perform 3 splits on this particular substring. All right, and let's examine each case one by one. So I'm going to put 1 here because for the split which I'm making, and C, the value of C is going to be 0. So it is going to be 0, and then I have to take the value of PAD. So what is PAD? So PAD is this cell, P to D. So it's going to be 2. So I will get the answer as 3. All right. Now when the case is CB and AD, so 1 is already going to come. Let's examine CB. What is CB? CB is this value, C to B. So 1 plus 1. Okay. And AD. So what is AD? AD. So it is again 1. So I get 3. I get 3 as the answer, which is not less than this 3. So I will put 3 over here for now. All right. Let's examine the third case. We have to look for the minimum value from all the 3 cases because we are looking for minimum number of splits. Please do keep that in mind. All right, so CBA, this is going to be 1 plus CBA, the value is going to be 2. Okay, all right. And then t, so for t the value is 0, so we are going to get 3 again. So since the values from all the 3 cases are equal, hence 3 stays over here. All right, now the subproblem becomes PATA. Okay, so I type it over here. BADA is not a palindrome. All right, so let's write all the splitting cases. BADA, then BA, DA, all right, then BAD and A. Let me omit all of them to avoid confusion. So let's start from here. So it is going to be 1 plus what is B? So B, the value is 0, so I get 0 over here, plus ADA. What is the value for ADA? So ADA is this cell, A to A, and that is 0 because it was a palindrome, so I am going to get 0 over here. All right, so my answer becomes 1. I put 1 over here. Now let's examine the second case. So it is going to be 1 plus. So what is BA? BA is 1. Cool. So I put 1 over here, and DA. DA is 1 again. So I put 1 over here. So I get 3 as the answer, which is not less than 1. So 1 stays over here. All right. Now I have made a mistake. I have put ADA over here. Okay. So BAD and A. Let me put 1 plus. What is BAD? So BAD is this cell, B to D. So it is 2. And we put 2 over here, plus A. So what is A? A is 0. So this again gives me 3. Now 3 is again not greater than 1. So 1 stays. All right. All right. Now the length of the subproblems increases to 5, which is also the length of our string. So we are at the final stage now. All right, so I'm going to put CBATA over here. Let's write all the cases over here, all the splitting cases. So first is going to be C, then BATA, then CPATA, then it's going to be CBA and DA, then it's going to be CBAD and A. So you can see, if you notice, that we have solved a couple of subproblems from all these cases earlier. Okay. So let's examine this one. It's going to be 1 plus the value of C is 0 plus BADA. So what is BADA? It is 1. B to A, BADA. You can also check the value like this. 1 plus 1. It's going to give me 2. I'm going to put 2 over here. All right. And then let's move to the next test case. 1 plus CB is 1. All right. CB is 1 plus ATA. So what is ATA? ATA is 0. ATA. So I am going to get 2 again. Okay. That's so cool. Now let's examine the third one. It is 1 plus CBA. So CBA is this 2. Let me write 2 over here, plus DA. So DA is 1. It gives me 4 as the answer. Okay, which is not less than 2. So I'm not going to put it over here. 2 stays. Now let's examine the last one, CBAD. So CBAD, the value is 3. CPAD C to D. Alright, the algorithm is going to read like this, C to D. Alright, so I am going to get 1 plus 3 plus A. What is the value of A? It's 0. So again I get 4 as the answer of this case, which is not less than 2. So 2 stays and 2 is the answer of our problem, which we have already seen. Now let's see the algorithm of this solution. So this is the algorithm. If is palindrome I comma j, that means the subproblem which is in question, then Tij is going to be 0, like we already saw it in the case of ATA, which was one of our subproblems. Else, if it is not a palindrome, then Tij is going to be minimum of Tik plus Tk plus 1j plus 1. So 1 stands for the minimum split that we are putting on, okay, in order to form our test cases, where k, the value of k ranges from I to j minus 1. The time complexity of this dynamic programming solution is O n to the power 3. Alright, so with this we have come to the end of this video. I hope you like this video. If you like this video, then do hit the like button, subscribe to Joey's Tech. I look forward to help you with algorithms and programming. Thank you and goodbye.